Okay, good morning to everybody. Let's continue our discussion on fluid flow measuring devices and how do we measure flow of fluids or liquids. No, um, we're done with what's the first orifices or orifice. Okay, we have discussed about how to determine for the different coefficients of the orifice and how to compute for the actual velocity, actual discharge of uh, f- discharge. No, okay. Next would be standard short tubes. Standard short tubes no, is we compute for the actual discharge using the same principle we have done before dun sa orifice. Actually, they have the same formula. No? What the difference would be sa short tubes, no? Since may tube dito, okay, so may tube dyan, short lang, na-minimize yung contraction ng jet. Okay, so the contraction of the jet is minimized, but there would be more loss of energy since yung particles ng liquid would be flowing at a certain distance dito. Meron siyang resistance dyan sa may wall ng tube, so there will be more loss of energy because of that, no? But the contraction of the jet would be minimized, so the actual velocity and actual discharge would be solved using the same formula before sa orifice or orifices. Okay. And the derivation would be the same also. Okay. Next would be nozzles or nozzle. Okay. We use nozzles to measure discharge. How do you measure discharge using nozzles? Although I think I did not give an example of this. How to solve for discharge using nozzles? Let's see mamaya kung mayroong example nito. Nozzle. Okay. Basically, we're going to use the energy equation sa pag-solve ng discharge. Okay. So, usually, nozzles, ito, pasensya yung drawing ko, medyo magulo. So, naglalagay tayo ng pressure gauge dun sa may, for example, ito yung hose. Okay. So, yung i-insert natin yung nozzle dyan. So, meron tayong pressure gauge. Yan to measure the pressure at that sa may inlet ng nozzle. Ito yung inlet part ng nozzle. So, idudugtong natin yan dun sa may hose or pipe. Pwede rin pipe. Okay. And then, to measure the pressure at that inlet point. And then, we apply the energy equation to solve for the velocity at point 2 sa may outlet na. So, lalabas yung liquid dyan. So, we can measure the velocity at that point, at point 2. And then, if we know that the cross-sectional area of the nozzle, then we can solve for the discharge. No? So, the discharge is simply equal to the actual velocity considering loss of energy when the particles of the liquids travel from point 1 to point 2, merong loss of energy because of that. No. That's why to minimize the loss of energy, meron tayong designed na na parang configuration nitong nozzle para ma-minimize yung loss of energy. So sometimes this is concave or convex, so depende, to minimize the loss of energy. Okay, so that we can, if the loss of energy is minimized, then perhaps we can neglect the loss of energy when we calculate for the actual velocity. So basically, the discharge is equal to V, velocity times the area. Velocity dito. Yeah, we can solve for the velocity at point 2. So we know the velocity at point 1, the pressure at point 1 also. We can solve for the discharge. We can solve for a discharge in terms of the velocities later on. So Q1 is equal to Q2. So we express V1 and V2 in terms of Q para minsan na yung pag-solve natin. So V1 in terms of Q, since from the law of continuity of flow, Q1 is equal to Q2, then that's definitely equal to the discharge in the entire system. Okay, so we express V1 and V2 in terms of Q. Then if we know the pressure at point 1 using the pressure gauge, and we can definitely solve for the discharge in the system. That's how we solve for the uh, discharge using a nozzle. Okay, next is the Pitot tube. Pito, I think the last T there is silent, so it's Pitot tube. Okay. So Pitot tube is a bent L-shaped tube with both ends open. Ito, both ends open. Ito, open yan, open dito. But sometimes this is closed, especially when the pipe is highly pressurized. Kung hindi naman masyadong malakas yung pressure, then we can leave this to be open. Okay? So after French investigator who first used, so the name Pitot is after the French investigator who first used such a device for measuring the velocities of liquids. So Pitot tube are used to measure the velocities of liquids. Okay. So for this particular configuration, we can solve for the velocity dito. So yung increase ng height, so for example, naglagay tayo ng piezometer dito sa may pipe. So this is a portion of a pipe. Naglagay tayo ng piezometer. This is the pressure head. And then we have the Pitot tube located at this point. So the difference in elevation, difference in height between these two, let's say h. So the velocity is equal to square root of 2g h. Yan. So yung increase ng height na yan, that's what we call that's the velocity head, no? So we can solve for the velocity using this formula, no? So yung height na yan ay yan yun. Okay? So yan ang function ng Pitot tube that's used to measure velocities. Now, of course, I have discussed before that velocities varies at every section of the pipe, especially when the pipe is very large or malaki yung diameter ng pipe natin. So yung velocity dito would be different from this point, different at every section, no? So yung dito mas mabagal because of the resistance experienced by the particles at the wall of the pipe. And dito mas mabilis, no? That's why sometimes yung Pitot tube natin ilalagay natin at different sections, and then we solve for the velocities at each section of the pipe or the conduit, and then we solve for the average velocity. Ayan. Okay, so that's it. That's how we solve for the velocity, and then we can now solve for the discharge if we know the cross-sectional area of the conduit or pipe. For example, H here is equal to, let's say, 0.3 meters yung H natin. So remember, ang basis natin would be yung piezometer dito. Ito yung pressure head natin. So an additional head would be contributed by, so dadalo yung tubig dyan, papunta din, may papasok na liquid particles dito. Pupush niya ngayon yung liquid. So aside from the pressure, ito, mayroon pang kinetic head yan due to velocity. So tataas pa yun because of the velocity head. So whatever is the increase in terms of height, okay, ang basis natin would be yung piezometer natin dyan. That would be the velocity head. If we know the velocity head, we can compute for the velocity at that particular section of the conduit. Let's say, for example, H is 0.3 meters, then the velocity at that section, or the velocity in the pipe, is equal to square root of 2g. H, let's say 0.3. So the velocity is equal to, that's 2.426 meters per second. It's the velocity in the pipe or conduit. Now if we know the cross-sectional area, of the pipe. Let's say the diameter is let's say diameter is 0.4 meters, then you can compute for the discharge as pi 0.4 squared over 4 times the velocity 2.426. So the discharge in the pipe, okay, is equal to that is equal to 0.305 cubic meters per second. So that's the discharge inside the pipe. Sometimes you multiply this by a certain coefficient. We call this the coefficient of Pitot tube. Pitot tube pala, sorry. The coefficient. But sometimes the coefficient is neglected because the difference will be very very small. Naman. We multiply it by the velocity to solve for the actual velocity. Okay, yung Pitot tube natin. So usually ang coefficient natin is ranges from 0.9 to 0.99, something like that. So maliit lang actually yung difference niya dun sa actual, sa theoretical velocity. So basically this is the theoretical velocity, you know. So the theoretical velocity. So but sometimes or most of the time we already neglect the coefficient of Pitot tube. Kung given naman yung coefficient of Pitot tube, then we multiply it by the theoretical velocity to make it actual. Okay? So, for example, kapag given natin ay meron tayong coefficient na 0.99, okay. So, the actual velocity then is equal to, i-multiply lang natin 0.99 times 2.426 meters per second. So, the actual velocity is equal to 2.402 meters per second. Is the actual velocity pag given yung coefficient of Pitot tube natin. Kung hindi siya given, ibig sabihin we neglect it. Although most of the time we neglect the coefficient of the Pitot tube kasi the difference will be quite small. Okay, pero pag given, ito yung gagamitin natin na velocity to compute for the actual discharge. Ayan. So yan yung Pitot tube. We will have more examples of this particular problem, okay, later on. Okay. Okay, let's try to solve problem number 3. Problem number 3 deals with the application of Pitot tube in solving for the velocity of flow in a certain pipe. Usually, Pitot tube are used to measure the flow of gases, you know, gases yan. And usually kapag if we measure the flow of gases, our gauge liquid would be water. Okay, water yan. Okay, so a Pitot tube in a horizontal pipe in which air with a density of 1.24 kilograms per cubic meter is flowing. It's connected to a manometer containing water. So this is the manometer connected, yung Pitot tube natin connected siya sa isang manometer. Again, we would usually connect the Pitot tube in a manometer, U-tube manometer kapag medyo highly pressurized yung conduit, no? Pero kung hindi naman open siya. But in this case kasi air kasi ito, no, kapag open yan, lalabas yung air. Kung lalabas yung air dun sa may Pitot tube tsaka sa manometer. So dapat close ito. Close yung system natin, close yung manometer natin para hindi lalabas yung air. Pero kung liquid, okay lang kasi hindi siya highly pressurized. Kapag highly pressurized kasi yung liquid na nag-flow, the liquid might, you might be needing very, very long Pitot tube and very, very long piezometer. Okay? So, that's it. Let's continue. If the difference in water levels in the manometer is 8.89 centimeters, what is the velocity of flow in the pipe assuming a tube coefficient of 0.99? So we have a tube coefficient given siya as 0.99. Okay, we multiply it by the theoretical velocity to solve for the actual velocity. So we're solving for the actual velocity in the pipe. Okay? So again, close ito because we are dealing with flow of gases. Kung open yan, nilagay natin sa tuktok, open yan, syempre lalabas yung gas doon. It's not practical. It's not a practical thing to do, no? Okay, so kaya kinakabit natin yan sa YouTube manometer. YouTube or manometer. So hindi siya open type. Okay, so what do we do? How do you solve for the velocity? So we are solving for the velocity in the pipe. So how do you solve for the velocity? So we apply the energy equation to solve for the velocity. Okay. So when we apply the energy equation, we need 2 points, We need 2 points and we assign those points as much as possible to minimize. Ilagay natin yung mga points na yon so such that the number of unknowns in the equation, since we only have one equation, the number of unknowns in the equation would be minimized. Saan nilalagay yung dalawang points na yan? Perhaps we can put those points. First point natin dun sa tuktok ng leg ng manometer. First point natin. And second point would be dun sa may opening ng Pitot tube. Yan. So, 1, 2. And bakit dun natin nilagay? Okay. Yung points natin. Okay, so tuktok dapat ng manometer so that we can solve for the difference in pressure later on. So we don't know the pressure at point 1. We also don't know the pressure at point 2. But since we have put those points dito sa may manometer natin, then we can apply manometry to solve for the difference in pressure between those 2 points. So this would somehow eliminate the unknown pressures in those points, And inilagay din natin yung point 2 dito sa nguso, sa opening ng Pitot tube, kasi at that point walang velocity. Walang velocity dyan. Pero at point 1, merong velocity. Yun yung sinosolve natin. V1. Dito sa point 2, V2 is equal to 0. Bakit 0 ang velocity sa may point 2? So you try to imagine the air is flowing. So may pumupuntang air dyan hanggang sa mapuno na hindi na siya pwedeng makompress. So ipupush niya ngayon yan. Yung liquid, yung water, ipupush niya yan papunta doon. Kaya mas malaki, mas mataas yung height ng liquid ng water dito compared dito because of the kinetic energy or kinetic head contributed by the flowing gas or air dyan. Ipupush niya yan hanggang sa magiging stable na siya na ganyan, stagnant na siya. That means yung air dito hindi siya nag-flow kasi hindi niya may push pa ganun. The air here is not flowing, stagnant. So if we put point 2 at the mouth of the Pitot tube here, then definitely there's no velocity at that point. So we call that the stagnation point. So stagnation point ang tawag natin dyan. Okay, so let's try to write the energy equation. We have V1 squared all over 2G plus P1 over gamma plus Z1 is equal to V2 squared all over 2G plus P2 over gamma plus Z2. Okay, so we're going to neglect the loss of energy from 1 to 2, neglect na lang natin such that the velocity that will be solved later on would be the theoretical velocity. So how do you solve for the actual velocity? We just multiply it by the coefficient of the Pitot tube. Okay, and since the pipe is laid horizontally, so V2 again is 0, stagnation point. Of course we have P1 and P2. V1 is what we are solving, the velocity inside the pipe. And since the pipe is laid horizontal, that means na magka-level lang yung point 1 at point 2. They have the same elevation that would make Z1 and Z2 equal. That means magka-cancel yan. Iliparan sa kabila, cancel yan. So we're left with this equation. So V1 squared all over 2G plus P1 over gamma is equal to P2 over gamma. That's it. So we are solving for V1. That is the theoretical velocity inside the pipe. But first, we need to solve for um, the difference in pressure between points 1 and 2. Ano? Okay, so we have, let's set to the right, i-transfer na lang natin to sa right side ng equation. V1 squared all over 2G is equal to P2 over gamma minus P1 over gamma. Okay, or that is equal to P1 or P2 minus P1 all over gamma. So we need, so gamma of air, since we're dealing with air here. Okay, so we need the difference in pressure between the 2 points. And how do you solve for the difference in pressure? Now, meron tayong differential manometer dito. It's a differential manometer, and differential manometer obviously is used to measure the difference in pressure between 2 points. How do we do that? So decide to recall, remember fluid mechanics, hydraulics once, when we applied the principle of manometry or pressure heads or pressure adding of pressures when we solve for the pressure or difference in pressure between points. So let's try to add pressure or pressure heads from 1 to 2 or 2 to 1. So it's that. Okay. So we add pressure heads from 1 to 2 na lang. Let's try to label yung points of equal pressure. Let's say this is point A, this is point B. And this distance, let's say this is X na lang, yung distance na yan from point 1 to A. Okay, so we add pressure heads or pressure na lang. Pressure na lang iikot natin. I-add. First, we also need pala, kasi since ang unit weight natin should be unit weight of air, pero ang given natin is density of air. So, i-convert mo natin yan sa unit weight. So, unit weight of air is equal to air lang. 1.24 kilograms per cubic meter. Multiply lang natin ng gravity. And 81 meters per second square. That would give us a unit weight equal to 12.1644 newtons per cubic meter. I hope you can read that part. 12.6 or 16 pa rin. 644 newtons per cubic meter. That's the unit weight of air. That's 12.1644. Okay, next is we add pressure from 1 to 2. So let's start at 1. So we have P1, which we do not know. And we go down to point A. So that's unit air pa rin naman yan. So that is unit weight of air. That's 12.1644 times X. So gamma H lang. Okay. So for pressure, that's gamma times H. Gamma of the liquid or fluid times the height. And then from A to B, so we go down. So plus when we go down, since pressure increases with depth. That is, convert natin to sa meters. 0.08 gamma. Sorry. The liquid is water, so that is equal. The gamma of water is 9810 newtons per cubic meter times height of water, that is 0.0889 meters. Okay, so this, ilagay natin yung mga units na lang. This is in newtons per cubic meter. Ito, X is in meters here. Okay, then from point B to point 2, so we go up, so minus point B to point 2 minus, we have gamma of air, so air naman na yan, We have 12.1644 newtons per cubic meter times, ang distance yan, x plus 0.0889 meters. That should be equal to the pressure at point 2. Okay? So we simplify this entire equation. X could actually be eliminated from the equation. Okay, itong terms na yan would cancel. So we're left with P2 minus P1 is equal to, since naka-Newton yan tsaka meter, the resulting value in pressure, difference in pressure would be in pascals. So that is 871.02760276 pascals, which is in newtons per square meter. Yan, since we know P1, P2 minus P1, we can substitute the value dito sa first equation natin. Then we can now solve for V1. So let's try to do that. Okay, so we have V1 squared all over 2G, that's 9.81, equals P2 minus P1, that's 871.0276 pascals, divided by gamma. I told you already, it should be gamma of air. So gamma of air, that is equal to 12.1644 newtons per cubic meter. So we're left with V1 in the equation. So V1 is equal to 37.4818 meters per second. Okay? I think yung module natin ay hanggang dito lang yung na-solve. Pero we should have multiplied yung CP to solve for the actual velocity. So the actual velocity is simply equal to CP times the theoretical velocity. This is actually the theoretical velocity inside the pipe. So nagkakaroon tayo ng coefficient because of loss of energy, ano. So yung pagpasok ng yung flow ng liquid dito ay nagkakaroon tayo ng loss of energy. So pag magkaroon tayo ng loss of energy, that means yung solve natin na theoretical, hindi yun yung actual na velocity. So meron tayong tinatawag na tube coefficient, or the coefficient of the Pitot tube, CP. Now to solve for the actual velocity, we simply multiply CP and the theoretical velocity. So it's 0.99 times 37.4818 meters per second. So the actual velocity is equal to that is equal to 37.107 meters per second. So that is the actual velocity. Okay, that's how we solve for the velocity in the Pitot tube. Now, if you're interested to solve for the discharge, you simply multiply the actual velocity and then with the cross-sectional area of the conduit or pipe. Okay, but Pitot tube is used to measure velocities. Okay, velocities ang mini-measure ng Pitot tube. Okay, so again, the procedure is how do you solve for the velocity? We apply energy equation. Okay, then we will arrive with an equation in terms of V1, which is what we are solving, V, velocity, and then in terms of pressure also, no? And we can solve for the difference in pressure using manometry. So we add pressure or pressure heads from a certain initial point to a final point. Okay, and then after solving for the difference in pressure, you substitute that din sa equation, first equation natin in terms of velocity. And then we can now solve for the velocity. Kapag given yung coefficient ng Pitot tube, you multiply it by the theoretical velocity to solve for the actual velocity. So ganoon lang kasimple yung pag solve ng velocity using Pitot tube. Okay, so that's it. See you sa next video.